I am Ying. I am a faculty at UC Berkeley, and I've been there for 25 years or more than that. And I've been, for the past 15 years, I've been involved in quite a few open source projects. Started with Mesos, precursor of Kubernetes, Spark, Apache Spark, Ray, AGLang, VLLM, and also, fine-tune some models, open source models at that time, Vicuña. From that follows also another projects about chatbot arena to evaluate these LLMs. And then I also have my entrepreneurial side, started a few companies, including Databricks.
Mm-hmm. Okay.
I'm Jonathan Cohen. I'm a vice president of applied research at NVIDIA. Along with Brian Canzaro, I co-lead the Neotron program. My team also develops a lot of the Nemo platform, and I guess a lot of it started on my team and has kind of moved to other parts of the company, and a few other applied research projects. But obviously, a lot of what we do is in the open, and that's a really important strategy for NVIDIA, and I'm sure we'll talk more about that. But most of the work from my team is either open weight models or open source software.
Thank you. Ranjay.
Hi, I'm Ranjay Krishna. I am a professor at the University of Washington, and I'm also director of multimodal and embodied AI at the Allen Institute. The Allen Institute is a nonprofit organization. It's a research organization. And our mission is to tackle the world's hardest challenges by providing AI solutions. My group in particular is focused on building vision language models as well as robotics foundation models. And everything that we build is completely open sourced, meaning that we open source the entire training suite, including the training data, the training code, the infrastructure. We also open source all of our evaluation data and all of our model checkpoints and weights, meaning you can reproduce everything that we build completely from scratch.
Ying.
Hi, everyone. My name is Ying. My journey of open source started from my PhD at Stanford, and also when I was visiting Berkeley, actually with Young Stoica. We initiated a nonprofit org called EECS, and we did a bunch of open source projects there. Starting from Vicuña, which is open source model, and Marina, that's evaluating many of the open source models. And SGLang is an open source inference engine. In last year, we have seen huge growth in the open source community for SGLang development. And many of the core developers, we launched a company called RadixArk, and now I'm a CEO and a co-founder of RadixArk. And this company will keep focusing on building AI infrastructure and with the openness as the core of its value system, and continue to build inference engine on SGLang and RL engine we named Miles. And this long way to go for building the open source ecosystem.
And Jeff.
Hi, sorry to be late. I'm Jeff Boudier. I lead commercial products, specifically at Hugging Face. One of the favorite parts of my job is to work with our partners, including NVIDIA. Our goal is that every person in the world, every company in the world is able to build and use their own models. Who here doesn't have a Hugging Face account? Okay, nobody, you do. So we still have work to do.
So thank you so much. So as Amanda and I were talking before you guys came up, today's focus is open source and business. So there was a time we used to talk about open source purely. I mean, there were businesses like Red Hat that came from Linux and stuff like that, but it was still more or less a values question. And now the number of companies that we have seen out there who are, including yours and Ying's and all that, the revenue potential, everything is amazing. And what's your thought about it? Like, what's making that difference? And what do we need to continue to do that? And obviously it's a good thing, but do you have an opinion about it?
I think from the business model, obviously any company wants to get to the product market fit. And having an open source project which is successful, addresses half of that equation, the product market fit, because the open source project is successful because people use it and people use it because it solves some of their problems. So solve a problem. It's a proof of existence, so to speak. Now, the other part of the equation, whether you can make money on top of the open source, right? And I think then, actually cloud and so forth provided opportunities to do that, like we did early on at Databricks, by providing a managed service in the cloud for the open source, then add more value in terms of performance, cost, and features. So I think that's kind of part of the recipe, how companies, at least one approach for companies to commercialize open source successfully, and obviously other companies were, Confluent, MongoDB, and obviously Cloudera and Hortonworks at some extent. So that was one approach. There are other approaches like Hugging Face and so forth, and I'm sure we are going to see others. But, it is possible to build business on the open source.
Yeah. So, John, you are leading the whole Neotron training effort, and that's been a big news and initiative and a lot of excitement around it. So what was the aim towards doing that? One is open source, enabling the community.
Yeah, the idea behind Neotron is, speaking, if I were to speak purely self-interested from NVIDIA's perspective, which isn't exactly how I think about it, but if you take that frame even, it's in NVIDIA's interest to have great AI everywhere. We believe it. We believe it's good for everybody. We believe it's good for the ecosystem and the economy. There's so many businesses that are built on AI, and we want to enable all of them to be successful. And the idea behind Neotron is, if everybody were to train their own models from scratch and gather their own data sets and build their own software, that would obviously be incredibly inefficient. And if our goal is to help the entire ecosystem move as efficiently and quickly as possible, then we want to ask the questions, well, what are the things that we can do once and then share with everybody?
Yeah.
And one of those things is we can build foundation models. So we do that in the case of Neotron, we do that in the case of world models with Cosmos, we do that in the case of robotics with Groot. But across NVIDIA, we have many of these foundation model programs, each to serve a different industry or technical need that powers a different industry. And then all of the R&D that goes into it, as much as we're able to, we also open source. We open our data sets. We open source our training recipes. We publish these detailed technical reports, like we just published one on Neotron Super. That's very detailed. That really explains what we did and how did we do it and why did we do it. And the reason for all of that is we want to teach the entire industry, because we want the whole industry to move as quickly as possible.
Yeah. So Ranjay, last year GTC, I had a great fireside chat with Ali on open source, and he had a lot of interesting ideas, and he had almost an emotional response to every question I asked. But one thing he focused a lot on was benchmarks. I think now we have these efforts, Neotrons and a lot of other companies doing models, but at the time there was a question, what do you do in open source? Do you have any thoughts? And please feel free to add other activities like the multimodal aspect that you mentioned.
Sure.
Yeah.
So, evaluation has always been a big part of the entire training cycle. It's probably the most important part.
Yeah.
I think a lot of times what we struggle with in the open source community is we build benchmarks become static, people overfit to them, and it's then this sort of process, this loop where you then have to go back and regenerate new benchmarks to keep track of actual progress. And oftentimes that process becomes sort of alienated from actual use cases. And so it becomes harder and harder for people who aren't directly building models that are being used by users to build very effective benchmarks. There's been a lot of efforts trying to build dynamic benchmarks over the last couple of years that quickly adapt themselves to the change in use cases. But I wouldn't say that those directions have completely been successful yet. There's still a lot of research questions left, but I'd love to see them continue. In the multimodal and embodied AI space, it's still very nascent. When you look at multimodal models, I mean, they're still so far behind in their capabilities. People are still building spatial benchmarks, spatial understanding benchmarks. These models barely understand 3D space. They barely make sense of, where things are, how far they are. I mean, sure, you see some demos where things work well, but even for simple cases like counting, they're unable to reason about, hey, I saw this bottle here, I looked away, I came back, oh, that's 2 bottles. These simple sort of mistakes shouldn't happen, and it's partially because we do have an evaluation problem. In embodied AI, I would say it's even worse because it's a big systemic problem. It's not just about coming up with one evaluation for one set of tasks, but the kinds of things we want to build robots for is so diverse, and the environments we want them to operate in is even larger.
Yeah.
I would say that it's a bigger and bigger problem.
Yeah, yeah. Thank you. I'll come back to that. But Ying, you're a good example of, you started open source, amazing community built up, great job there, and then you have started something, a business. So, coming back full circle to the question I asked Eon is, how do you think about it? How do you sustain Miles and SGLang and then a business that's building on something that's open source?
Yeah, I would say this is actually another direction. We wasn't initially thinking about business. We initially want to make open source, do the open source work, and share it with people that you can all use it to run something else on top of it. We want to make it successful. We want it to be used by people and maintain high quality. And then we discover, every open source project, although at the spirit of it is we want people to all join to develop, co-develop, to join, build one thing, make it great. But if you want to make it really successful, always there's something needs to be behind to lead the project direction and push for everything around. It just will become much more complicated on the road when it's getting more and more successful. And launching companies is an inevitable choice to be the force behind of it. So it's because we see the huge potential, we want to continue the journey. So have a company becomes a passive choice that we need to do it. And and we also believe if we're doing this, people are all using it, and we see more and more people using it. Definitely, it has the value that creates other values. So if it creates value, then there will be people will be happy to buy it, and which we have just proved which is true, which is already happening. And this is the open source project as an asset is enabling a lot of things on top of it, and the enabling layer expands more than the core itself, and the expansion of how to utilize this open source core, how we can unleash the power that it can do for the other upper layer customers is what enterprise layer will do. And that will be in the business part. Definitely, we are still at a very early stage. A lot of things we need to figure out, but I believe the direction is we hope to build a whole thing around of this core and teach people how to utilize in your real production scenario, make it stable, efficient, and generalizable, modularizable. Also have a way to even further grow it and fork it, second time develop it to enable more possibilities. And all that path is a business itself.
Yeah, thank you. So there's little time left, and I want to get to a lot of interesting questions. So Jeff, maybe I jump ahead a bit. So you guys started quite a few years ago, and the question that you ask is, who doesn't have a Hugging Face account? So I think you would have a best insight into the distribution story of it, right? So you started with model weights, and then eventually it became a lot of different things. Now there are papers, and then there are, different utilities, and then your own opinions about things. So how do you think businesses or people utilizing different aspects of the infra for an end-to-end system?
Yeah, it's hard to believe that Hugging Face is about 10 years old.
Yeah.
number of models and data sets and applications has been increasing and accelerating. I don't think this is something that we've shared publicly yet, but we crossed over 5 million open models, data sets, and applications on Hugging Face, which really shows like the adoption of open source. And whenever there's a new important model like Neotron 3 Super that just landed, like Olmo 2 that recently landed, it creates sort of an ecosystem around those models. And I think there are a lot of things that happen through Hugging Face as a distribution platform that not necessarily like super visible as a user of the community. So the first one is like that scale. And today we serve all these models and data sets. There's like hundreds of petabytes a month, right? So that means that we're serving models at the same sort of scale that Netflix is serving movies. So it's a little bit crazy. Another thing is that when we talk about AI, we think a lot about LLMs. But actually, like if you look at the top 10 models in terms of like trending on Hugging Face, like most of them are not LLMs, right? They're going to be speech to text. They're going to be image generation, multimodal, etc. And then I think local AI is another thing that's not necessarily like super visible. And it speaks to like how AI builders are now taking AI into their own hands, and there's like that stuff that want to keep private and run locally, and there's the stuff that they need a lot of intelligence and want to run on the server. And we see that very clearly in the numbers. If you're interested in like all these like numbers, our society and policy team just published a new report on the state of open source AI with lots of figures in there.
Awesome, thank you. So coming back to the initial question I asked you, Ian. So you have this concept of 5-year labs, and all of them have spawned some really interesting companies and open source projects. So how does it look like? What does it make? Like, you can tell that story better than anyone. Like, what components of OSS does it take to make a successful business? You have done everything from Databricks to Anyscale to LM Arena and then SkyPilot.
Yeah. So I think, again, this is for people who do not know at Berkeley, one kind of labs we have, these are 5-year labs. And they started long time ago in beginning of 80s, so 45, 46 years ago. Actually, the first lab was the one which created risk reduced instruction set computer, which is dominating now the CPU world. And then these 5-year labs, they have a mission, and it's a group of faculty and students which are excited to work on those problems. Also, I would like, as a context, that for a long time, and even before the open source was fashionable, Berkeley was a cradle of the open source. It's, maybe people remember about Unix BSD. BSD stands for Berkeley Standard Distribution. Maybe people remember about Internet, TCP/IP. This TCP/IP was a project which was open source at Berkeley, and Ingress, the first relational database which was open source. So you're just kind of, like they say, we are in the, on the shoulders of the giants. And but now to get, and then we have a series of projects, of labs, Rad Lab, AMP Lab, Rice Lab, and now Sky Computing Lab. And in each of those, there are a few, one or more open source projects, which actually became quite successful. Like, it's like Apache Spark, Ray, SkyPilot, thanks for, and HGLang and VLLM, which are the top open source project when it comes to inference, LLM inference. So what gets there is like, it's something very organic. So first of all, these projects kind of are, kind of provides the direction in the lab and so forth. But at the end of the day, it's a group of students who are passionate and happy to work together to make it happen, right? So that's kind of actually the key. The lab itself is built that basically everything we do, it's open source, permissive license, Apache 2.0, and we don't produce any patents. Everything is for public good. And then this people, like create projects, and at some point, if some of the project is successful, some other companies are starting to use it. And now the question, this company is starting to use this project, say, okay, what will be, if I want to bet on this project, what will happen when the students graduate and so forth? And then there are a few choices, right? It's like one choice, it's basically saying, well, I am graduating, going to academia, the project dies. The other thing is that, maybe some other company wants to take over the project. And actually, with Apache Spark, we actually wanted to shop around for some company to take over, right? Because, we didn't necessarily want to start a company. We want the project to be successful. And the other one is to start a company, right? So these are so in many cases, the project, like you heard Ying's mentioning, the project, the company, it's also results from the passion of people to push the open source to be successful at the next level.
Yeah, and it gives a different kind of energy to the students. Like you're doing PhD, and then there's a potential of seeing the real world implications.
Yes, and I think we build a little bit of more ecosystem, so people learn from each other because it's a little bit of that. But fundamentally, it's down to a group of passionate students working very well together and pushing on the project and wanting to take it to the next level.
This is an amazing idea. So on the same lines, John, right? So I haven't heard much about Neotron Coalition other than keynote slides, but I've been hearing buzz for a while. So now, since we're talking about like research to business or open source to business, what entails Neotron Coalition? I'm sure it's not just models. It's know-how, it's knowledge, it's data sets, it's a lot of things. How are you thinking about it?
Yeah, well, again, the idea, our motivation is we want to power the entire industry to do more AI.
Yeah.
What do we have? What does NVIDIA have as an advantage? Well, we have resources. It turns out training a state-of-the-art model is getting more and more expensive. And it's harder and harder to sustain that, right, for companies to do. We're motivated and we have resources. Turns out we make money. And so we can put those resources into training these models. And that's great. So we do this for the benefit of the community. But when you think about it, two things. One, it's difficult to build something for the benefit of the community when that community doesn't have a say in what you're doing. And so it certainly makes sense from that perspective. We should invite the community to join us. We bring resources, but people bring their own ideas and their own interests and their own expertise. And then the second thing is, it certainly isn't the case that every smart person in the world works at NVIDIA. There's a lot of smart people. In fact, it turns out more smart people don't work at NVIDIA than do work at NVIDIA in the world, right? And so if our ambition is to build something that's going to be really great, and we need lots of great ideas to do that, it would make sense to try to involve as many of those people outside of NVIDIA as possible. So that was the original motivation of the Neotron Coalition is, can we find like-minded companies that are also interested in and benefit from the creation of great open models and data sets and technology? And then can we create some kind of framework that actually allows us all to work together? I think the details there require that will keep evolving, but it includes things like you're saying. We can certainly collaborate on data sets. We've been pretty good about opening our data sets, releasing our data sets. AI2 has been exceptional about releasing their data sets. That's a great opportunity for us to work together, for example. Lots of companies have either access to very interesting data sets or capabilities to build interesting data sets that they realize is to their benefit to share. And so, that can be part of this too, right? And then another aspect is when you train a model, before you PyTorch train, you spend most of your time thinking about all the decisions that you have to make. What's going to be our model architecture? Are we going to use this flavor of transformer or that flavor? Or are we going to use this data set? What's going to be our mix? Or, just a lot of decisions to make. And the way you make those decisions is through research studies. ablation studies or comparative studies or all these things. That's an area where there's a lot of opportunity to collaborate. And so I think one of the main areas of Neotron Coalition will be a lot of these member companies are doing their experiments and we're doing our experiments. And it turns out if we share what we're learning with each other, we can actually all do a better job.
Okay.
And I think that's going to be the main mechanism of a lot of the collaboration.
And is coalition all formed or it's open for applications?
Well, I think we've announced kind of the initial collection of companies. Our ambition is that I think there's like a practical aspect of what we can manage, but our ambition, over time is that it would have hundreds of members. Really be an enormous organization.
Awesome. Yeah, successful. So coming back to you, so you mentioned that multimodal severely lacking in benchmarks and evals.
Yeah.
But overall, what else? Because I agree with you, I don't see much out there. But what else is needed in terms of infra, data sets, everything because I'm sure 2-3 years from now, that's all we will be talking about.
Sure.
Yeah.
Let me start off with multimodal first, and then I'll talk a little bit about Embodied as well. So in multimodal, when we first started thinking about building vision language models, all the proprietary ones that were out there, including GPT and Gemini, they were all closed source. There was nothing that we could really build on. There were, of course, some data sets out there, but all of those were very small scale, and they were mostly academic data sets. And the general consensus in the community at that time was that we could scale up vision language models the same way that we've been able to scale up language models. But we kept finding that even in these large models like GPT and Gemini, they kept making mistakes that they really shouldn't be making at all. And it was really hard for us to investigate why without really having open models to play around with. There were, of course, some models that were open, but again, the training data was completely closed off. So we began by starting to analyze training data sets. And we quickly realized that most of the training data sets that people were scraping from the internet to train with, they contained text that barely talked about the visual content at all, which makes sense when you think about it, right? When you upload an image on, let's say, your social media, you don't usually describe the contents. You describe how it matters to you. And so that's what people were training on. And so it's no wonder that these models were lacking all of this information that's actually in the images. And so we started building our own custom data sets at scale, trying to get people to talk about things that they wouldn't necessarily talk about usually. Talk about all the boring things in the background of an image, talk about where things are relative to each other. And once we collected that data and trained our very first model, we were surprised to find that it outperformed GPT. So our first model in this series was Molmo, and it was able to beat all of these models, these proprietary models that were much, much larger. And so that was very surprising. So, for us, it seemed like scale wasn't everything in vision language. And so clearly there was a need for better studies, need for data sets, and of course the entire evaluation suite was still very much in development at the time, and it still is. Now, along the same lines, one of the other things we've been looking at in my team is, of course, embodied AI and robotics. And the problem there is even more dire. You have all of these corporations that are training these large foundation models, and some of them have released these models. Thank you to NVIDIA, for example, for releasing Groot, or Physical Intelligence for releasing Pi. But again, we don't know anything about their training data. And so we have very little information to actually understand what it's going to take to replicate these results, why these models fail, and why do they make the mistakes that they do. And so again, our solution here is to, try to see if we can build robotics data sets. And of course, it's way too expensive for us to build. It's taken billions of dollars for a lot of these other companies to build robotics data sets at all, because you need to train people to teleop these robots and make them do tasks. And it's a lot of hard work. Instead, our solution has been to go to simulation. And so we've been scaling up simulation environments and building out hospitals, conference rooms, people's homes, all pre-populated with 3D assets and all kinds of variations that you might encounter in the real world. And now that we have these assets, we can then start generating data in them. And it's easy to generate data when you know where every single thing is in simulation. And now we can start studying these things at scale. And again, we've been surprised because we released a model last week called Multimodal. And it's trained completely in simulation, and it outperforms a lot of these foundation models that have been trained with real-world data.
Awesome. Yeah.
And again, it's because we're able to generate data across a wide diversity of things and actually study what it takes to build them. This is the kind of stuff that I think more people in the open source community need to be doing.
Yeah.
And again, we do release everything so that others can build.
We use it, yeah.
Yeah.
Yeah, that's awesome. Thank you. So it's all synthetically generated data.
Yeah.
Awesome. Yeah, that's great. I know we are running out of time, so I want to just not blitz through you, but like ask you one question, one more round. So Ying, so some things I've been observing about you, right? So you came as a student from Stanford, from under Eon, and then your work at XAI, and then the community you developed with SGLang. So, and this is something that I observed firsthand, like the feedback response that was so quick turnaround, that was really intense, and that garnered you a lot of support and more feedback, better product and whatnot. So now that you have a company, how do you see it going forward? Like, how do you continue supporting the community? How do you balance like what Eon was saying, right? Like building the open source and everything, that's half of it. Then how do you make money? And then how does community factor into it? I know you addressed it a little bit in the beginning. What's your strategy here?
Yeah. First, I think open source development, what it gave us is the network. It's a window for us to see the world.
Yeah.
It's a window for us to gain information, know about the market. Like you said, fast iteration of gaining feedbacks.
Yeah.
And all those information letting us being able to stand at the frontier of what's the new question, what's the upcoming question, what we can do to solve the next thing. And those information is actually the invaluable part for us to move forward to the future of a bigger scope, more ambitious vision. And the vision then, as young as an inference engine, we started from there. Mm-hmm. The RadixArk's ambition, we already leveled it up to the AI, just AI infrastructure, so including inference and training. And then our mission, in addition to still building the best open source and support the whole community, let people to share the knowledge, but also about build the infrastructure, which is actually usually the most complicated part. Build this thing in a good shape and focus on this, and put AI infrastructure as our first principle. When people consider the whole pipeline of building the best AI. Mm-hmm. And we focus a bit there, and then we work with other parties to eventually deliver the frontier AIs. Yeah. What we want to say is, from the core AI infrastructure, it can be a huge fan out of the various possibility of building models that can suit into different scenarios and solving different tasks and problems. And we believe that energy, we consolidate the effort into one focused component, and then be shared by all the other parties as where we generate the value and also how business will run. Mm-hmm. Because we do help those companies to bootstrap faster on moving towards the frontier AI. Mm-hmm. And we have shared the knowledge. We bring the knowledge from frontier AI that was holding a small group of people to everyone. Mm-hmm. And from that process, people will be happy to pay for the knowledge, but in different vehicles. Yeah. The knowledge in the vehicle of software, the knowledge in vehicle of services, or say the platform with toolbox that you can use. I mean, there could be different products, but essentially it's about people pay for the knowledge sharing.
Awesome. Thank you. And the conversation won't be complete, and I think Amanda is gonna yell at me if I don't ask. Agentic. So I know everybody's thinking about it, and then we're talking about agents right now. It's a single agent. It's doing some work, multi-horizon tool calling, and all that. And things are gonna get more complex, like multi-agentic training, and then you're sharing memory, your more complicated orchestration, scheduling. How's Hugging Face planning that era for yourself and the community?
Well, I think there are two dimensions. One is that we want to provide the tooling so that people can build their own agents. There's a lot that goes into it. Agents are systems, and so you have the reasoning part, and you need to interface that with the tools, and you need to provide it skills. And so all these different parts of it, we want to enable through our open source libraries and then through the repositories on the Hugging Face Hub. And then there's another piece of agentic that's really exciting to us, which is the democratization aspect, right? If AI proficiency was sort of like a video game with like 5 levels, then fine-tuning an open model would be maybe level 3, right? And so that was usually the work of data scientists within organizations. Today, that level 3, like you can accomplish at the beginner level because we now have, GRPO of using TRL, of an LLM, using a custom data set, like all these things. They're skills that you can provide, register to your agent, right? We now have like you do HF, that's our terminal CLI, register skill to whatever you're using, whether it be Claude or whatever, or OpenClaw. That changes everything because that means that the capabilities of building your own AI, customizing your models to your data becomes something that is available to all AI builders. I'm excited about it.
Thank you. So I know the time is up. Can I take 2 more minutes? No? Okay. Well, thank you so much for your time.
Nice try,
I know we couldn't, well, we started 5 minutes late. But I couldn't get to all the questions I wanted to ask, but thank you. This was very valuable, and it's up to these guys if they have time to have more discussions with you all. Thank you so much.
Thank you, Present. Thank you guys so much.